Hello, this is Mahendra Didia. This is a continuation of Module 11, which contains equipment and processes used in suspension. In previous module, we looked at the equipment. In this submodule, we would look at processes at lab scale, 100 milliliter size labs. This to emphasize this process is not going to be exactly similar to commercial scale processes, and many times this is the starting point of formulation. So we need to learn that. However, we should record as much information as possible so that scale up from lab scale 100 ml to pilot scale is done in a proper way. The processing stage in lab scale is polymer needs to be hydrated, particles of solids need to be hydrated with wetting agents, and intense mixing is required. And intense mixing, aqueous vehicle paired sequence of addition generally as polymers are mixed in dispersion media followed by hydration of the particles or the solids. This is a deflocculated suspension, and flocculating agents are added to make a flocculated suspension. However, in the lab scale, homogenizers are not generally used because of very small size, so we homogenize by using intense mixing. Let's look at preparation of 100 milliliter of suspension of sulfamethazine in which we hydrate polymers. Sulfamethazine suspension in clay, magnesium aluminum silicate, and cellulose sodium CMC are used as a suspending agent. And this formula, we saw that in earlier module. Sodium lauryl sulfate is a wetting agent. Saccharin and sucrose are sweeteners common in pharmaceutical industry to use methyl and propylparabens. First step is to hydrate clay and sodium CMC, both suspending agents, for about 24 hours using sodium lauryl sulfate in a 30 ml of water. Mix at low speed on magnetic stirrer. The drug sulfamethazine is added to the hydrated polymers, 30 milliliter. It needs to be very intense mixing, which would simulate high shear mixing. In separate 150 ml beaker with dissolved preservative, sucrose in 40 ml of water by heating at 50 degrees C and mixing it. Cool the solution and then add sodium saccharin to it. The active portion that's in step 1 and 2 is then added to the vehicle. Flavors are added and entire product is QS'd with water. Suspension is mixed with lab homogenizer at a mid speed or intense speed with a propeller mixer. Laboratory method, weight at each step be measured. Laboratory preparation of 100 ml of same drug sulfamethazine. In this case, polymer is carbomer 934. And as pointed out earlier, carbomer 934 requires neutralization step. Procedure in 150 ml beaker, hydrate the carbomer for 24 hours and mix at allowed speed and solubilization of carbomer into water. Suspend sulfamethazine active drug in 30 ml of water containing sodium lauryl sulfate and carbomer. Use again lab high shear mixing condition, intense mixing. Add 10 ml of sodium hydroxide to neutralize carbomer. At this point, viscosity of carbomer will increase and mixing speed needs to be adjusted to make sure the suspension is uniformly stirred. In separate beaker, dissolve preservative sucrose in 40 ml of water by heating and mixing. Cool it, add sodium saccharin and citric acid. In this case, vehicle phase is added to the drug phase. This is due to the small volumes and the viscosity of carbomer. By adding water into the carbomer phase, carbomer viscosity will be reduced. Flavors added, pH is adjusted to 5.5, and then finally suspension is mixed with a lab homogenizer or intense mixing. Let's look at the lab preparation of 100 milliliter of suspension of antacid and antiflocculant. In this sequence of rotation is very correct. In 150 ml beaker, charge the mixing tank. This would be your main mixing tank. Purified water of about 40%. In double beaker, disperse with high intense mixing methyl cellulose and add simethicone. In separate 10 milliliter beaker, mix of methylparaben and propylparaben with very small amount of water, 2% or 2 ml of water. Make a slurry and transfer that slurry into the main beaker, the main tank. In the main beaker, add magnesium hydroxide paste, aluminum hydroxide gel, carefully, citric acid, sodium saccharin, sorbitol, and flavoring, and continue to mix at higher speed so that the suspension of magnesium hydroxide and aluminum hydroxide is clearly visible. These two actives are now suspended in the vehicle. In separate beaker, take Avicel, hydroxypropyl cellulose, and mix with 13 milliliter of water. This is all added to the main beaker. So now we have a suspending agent added to the suspension. This is a different type of sequencing than we had seen before. For 100 ml, this is the type of process for the weight at every step so that we can translate that into the commercial manufacturing at later date. Once the material is QS, make sure it's uniform, add intense mixing to make sure that aluminum hydroxide and magnesium hydroxide particles are uniformly distributed. So we looked at different ways suspensions are made. This is common in suspension development to have several sub-steps to make sure that particles, actives are uniformly distributed.